Okay, so today we're going to talk about area and volumes of similar solids. Sorry about that. I am looking at I kind of like this one. I said to look at that one. Oh, that's because it's got the scale factor written, and here it's written in a different way. I think we're going to go with this one like I said before. Okay, so I don't want you to highlight anything in this section. This does not mean you're not supposed to know information. What it means is, oh, I have to take that back. Well, I'll point it out. I'm not really going to highlight it. What it means is I want you to know the information, but it's not something I really think you need to stress about memorizing. It's not even anything I'd worry about writing on the card. Stick with the formulas for the card. That way you'll know what you're doing. Don't just write down blank formulas either. Make sure you write down what they're for. You don't want to be figuring out what the volume of a sphere is and plug it into the volume of a cone. So make sure you kind of know what's going on there. Okay, so for example 2 on page 522, it says to find the scale factor ratio and base perimeters, ratio of lateral areas, and ratio of volumes for these pair of similar figures. I don't care about you finding all that stuff. This is what I care about. We're going to point out some stuff. So the scale factor for A is 2 to 3. In other words, a side here that's 2 is 3 over here. If it's 4 over here, that's 2 times 2, then this is going to be 6. 2 times 3. If it's 6 over here, then this is going to be 9. It was 2 times 3 to get the 6. Now it's 3 times 3 to get the 9. So the scale factor is 2 to 3. If you were to put any of these sides on top of each other, 6 over 9, it would reduce down to 2 over 3. That's the scale factor. Over here, the scale factor goes from 10 to 4. That reduces down to 5 over 2. Goes from 15 to 6. That reduces down to 5 over 2. So those are your scale factors. Now, look at the perimeter. They went ahead and figured out the perimeter of a side, and they said the perimeter is going to be 12 on this one, and because it's 4 plus 4 plus 2 plus 2, and 18 on this one because it's 6 plus 6 plus 3 plus 3. That reduces down to 2 over 3. They went ahead and found the perimeter or circumference over here, and it was 20 pi on this one and 8 pi on that one, which reduces down to 5 over 2. Okay, so perimeter and scale factor have the same ratios. Then talk about the lateral area. Over here for lateral area, they're talking about just the sides, not the top, not the bottom, just the area of the sides. So the lateral area over here, they got is 72. The lateral area over here, they got is 162. Well, when you reduce that down, you get 4 over 9. Okay. Over here, they figured out that the lateral area around the outside of this one is 50 pi times the square root of 13. The lateral area over here is 8 pi times the square root of 13. They reduce those down. Pi's will cancel out, square root of 13's will cancel out, and you get 50 over 8, which reduces down to 25 over 4. But wait a minute, this was 2 to 3, and this is not 2 to 3 anymore. This time they squared them. So for lateral area, you square the scale factor. In fact, over here, they squared it. 5 squared is 25, 2 squared is 4. For volume, they went ahead and figured out the volume of this and the volume of that and got 48 to 162. Then they figured out the volume of this and the volume of that and got 50 pi to 32 pi. They reduced both of those down and got 8 to 27 for this one and 125 to 8 for this one. Well, if you look at it, 2 cubed is 8, 3 cubed is 27, 5 cubed is 125, and 2 cubed is 8. That means that in order to find the volume ratio of similar figures, you have to cube the scale factor. That being said, down here in Theorem 1215, it says if the scale factor of two similar solids is A to B, then the ratio of corresponding perimeters or circumferences of the bases is A to B. Same thing. If the ratio of base errors, lateral areas, and total areas are A squared to B squared. In other words, you're going to square them. And for a volume, you're going to cube them. Now remember, it's the scale factor that's being done to, and they have to be similar solids in order for that to happen. That being said, that is enough information for you to be able to do your classwork and your homework. It's located on page 523, just like it was the last time I told you about this section. Numbers 5, 9, and 13, and then the homework, just like it was in the last time I told you about this section, numbers 7, 11, and 15. This is the last section in this chapter, which means you should be getting ready for a review and a test. Make sure when you do the review that you have your card with you, so you can make sure that every formula that you need, that you don't have memorized, ends up being on that card. If you need to get a new card and use that card as a way to write your new card, that's fine. But make sure, because it's got to be down to one 3x5 index card. So make sure everything that you need is on that card. You can write as large or as small as you want to. I don't mind. Please, please understand me when I say you need to write down what those formulas are. Don't just write A equals pi times R times L. You need to know that that's to find the lateral area of a cone, so that you can get some grand idea of what's going on. I wouldn't worry about writing down what total areas are in general, because in general, total areas can be found by adding up the parts. So as long as you know the lateral area of a cone and you know the base of a cone, you add them together to get the total area. I wouldn't bother taking up this space for writing that down. But that's entirely up to you and how much space that you have. Once again, this whole section is nothing but formulas. So make sure you have those formulas down on your card. Okay. Have a good day. When you're ready for your review, tell your mom. When you're ready for your test, tell her that too. Okay, bye.